This is a lecture on 2.2 solving complex equations. A lot of this is going to be review because of us having already talked about 2.1 and 2.3. But I did want to go over just a few things on here to emphasize the relationship between squaring and square root. When we square a number, it basically all comes from the idea of having a perfect square. And in this case, we've got a square that measures 2 units by 2 units. And when we talk about the area of this square contains a total of 4 square units. Now, I can't really say that it contains 4 square feet or 4 square inches because I don't know what the units are. It could be anything. And so we just refer to them as 4 square units. This guy is a 3 by 3 and it contains a total of 9 square units. This one 4 by 4, 16 square units, and then it just keeps going on. These numbers 4, 9, 16 are referred to as perfect squares. Those whole numbers are perfect squares. So the next one up would be 25, and then after that would be 6 times 6, which is 36, and then 49, and so on. So if we had one that was a 9 by 9, we would refer to it as 9 squared. Well, when we're solving equations, we talk lots of times about opposite operations, subtraction being the opposite of addition, multiplication being the opposite of division. Well, we are squaring numbers lots of times. So what's the opposite of squaring a number? Well, that's square root. When we square a number, we're basically taking that number, let's say we have the number 6, and we're squaring it and we get 36. And when we square, it means multiply this number by itself that many times. So 6 times 6 is 36. But if I do the reverse, if I start with 36, I'm basically asking myself, what number multiplied by itself is equal to 36? Well, the answer is 6 times 6 is equal to 36. So the square root of 36 is just 6. And here's an example using the number 7. Square root of 49 is 7. So in a nutshell, squaring a number and taking the square root of a number are opposite operations. The same concept holds true when we talk about cubes, cubic things, three-dimensional things. This is 2 cubed. It's 2 wide, 2 long, 2 high, giving us a total of 8 cubic units if we were looking there and count them. Over here we've got a 3 by 3, 3 across, 3 high, and 3 deep. That gives us a total of 27 cubic units. This one 4 by 4 by 4, 64 cubic units. These numbers 8, 27, 64, and so on are called perfect cubes because if we had a three-dimensional object that had those same measures on all sides, this is what it would look like. It would look like a perfect cube. And this is verbalized as 9 cubed, or 9 to the third, or 9 to the power of 3. Lots of different ways. And just like with square roots and squaring, cubing a number and doing the cube root are opposites of each other. And this guy right here should have a 3 in there, so a little typo in there. So the opposite of cubing a number is taking the cube root. So if we were looking at the cube root of 729, we're basically asking ourselves, what number times itself 3 times is equal to 729? And the answer turns out to be 9. So these guys are opposite operations, reverse operations, in a very similar fashion to how it worked for squaring numbers. And this kind of pattern exists for any powers. For example, if I had 2 to the 7th, that means 2 times itself 7 times. If I knew what that answer is, and I guess I can do that, let's say 2 to the 7th, 2 to the 7th equals 128. Well, if I started with 128 and I wanted to know what the 7th root was, I'd be essentially asking myself what number times itself 7 times is equal to 128. Well, if I were to put this in my calculator, let me scoot this up a little bit. If I put this in my calculator, the way I would do this is I'm first going to enter that little number there, and he's referred to as the index. So I would say, let me clear this out, say 7, and now I need to pull up not the square root, but just a general root, and that's right behind my caret key. So it's going to be second up arrow. You can see the little X guy there, and essentially what your calculator is doing, it's putting a 7 in where that X is. And then I'm going to put the 128 in. Hit an equal sign, and I get an answer of 2. 2 times itself 7 times is equal to 128. On this next page, and we're really not going to go over this in detail, it's just that I made this up a while ago and I really like it. I think there's a lot of good information in here, but at the sake of being, I don't want to be too redundant, and I like it so much I just don't want to trash it yet. But you can see how we're discussing the relationship between squaring a number, square root, cubing a number, cube root, a number to the 4th power, and the 4th root, and so on. And it would just keep on going. So that's the end of the introduction, and then we'll start with example 1.